Okay, hello everyone. So today we're talking okay. And here today we are learning about electric charge. Okay. So what is about electric charge? Maybe you have some question. Okay. So this is a brand new word when you first see them. Okay, so let's move to the first slide and to get a closer understanding about what is electric charge. Okay. So over here you can find there is a word called electrostatic charge. Okay. So maybe in winter, if you're in maybe United States or in England or like in the European or like in China, like you're in the northern country or like you're in the Australia, like northern and southern country, but not in the not very maybe close to the equator countries. Maybe you'll find that there is electrostatic charge in your daily life, right? When winter is come, you'll find that maybe when you put up your sweaters and you'll find that, oh, here is a little bit charge or like a little bit electricity blings on your body, right? So in a sense that once you take off your clothes, they have the electrostatic charge. Okay. So here's also an example like if a girl she is putting her hand on the ball, you'll find because maybe she's in the scientific places and she's just trying to put her hand on the electrostatic ball. Okay, and maybe the ball takes one charge, like negative charge, and each of her hair just like stand up like this way because they are all take with negative charge. Okay. So you can say these are an example of electrostatic charge and you have electricity in your daily life. Okay. So maybe for IGCSE lessons, we only discuss about the positive charge and negative charge, but in fact that there's only positive charge and negative charge in the world. Okay. So after many years discussing and scientists find that only positive and negative. And here's an example, like if you put in two positive charge rods together, you'll find that they have a repulsive force. And you will put two negative charge rods together, and you find there's also like the repulsive force. But if you're putting a positive charge and a negative charge together, they will have attractive force. Okay, so here is repulsive and here is attractive. So we have a conclusion for this. That is, if they are the same charge, they will have a repulsive force. Okay, and if they have a different charge, we think at this time we will have a like attractive force. So this is why these rods moving like this way. Okay. This is for the first part, negative and positive charges. Okay. So here, another part is about where the charges come from. And if you're learning the IGCSE chemistry or GCSE chemistry, I think this part is very easy for you because charges are just from the atoms, right? So atom is a base unit for a substance if you're discussing and to try to determine what is inside this the atom, okay? So if you see the periodic table, you'll find different atoms are shown in the table, right? And maybe first is hydrogen, and second is helium, and third is lithium, and many other elements after this, right? So for a single atom, we have the structure inside of this, like in this figure. You'll find there's a central part, and it's made by red ball and green balls, okay? And the other part is some orbit and some electrons are on itself, okay? So it's like just a solar system, like center is the sun, and maybe here Mercury, Mars, Earth outside of the sun, and you will find they're just moving on their orbit. Okay, it's like just this system. Okay, so for the charges, we can say that due to this structure, for a single atom, that the positive charge equals to negative charge. Okay, maybe here we have like 5 red positive charge right here, and we must have 5 negative electrons outside. Okay, so total we have 5 positive charge and 5 negative charge. Okay, like this way. So here we can say, oh, for electrons, we can find there is an outer orbit. Okay, I also remember a story that do you know that the scientists just kicked the Pluto outside of the solar system, right? This is because Pluto was attracted by another planet. So maybe the sun's attractive force is not very big for this Pluto. Okay, so we said that Pluto is not a planet anymore, and we can say that for here we can set electrons are just like Pluto, okay? It can very easily attracted by other things. Like if we have a strongly positive charge right outer here, and electrons will be attracted to these places, okay? And also, the atoms can gain electrons because new electrons can attracted by this positive charge, right? So for this, we can say only electrons can move, but positive charge cannot move because positive charge is in the center, okay? So first we have to know that this, okay? And secondly, if you want to make the object to have positive charge, so that you must lose electrons, right? Like if you have 5 positive charge and 5 negative charge in the atom, and you will find if you want to make it to same like to be a positive charge, then must lost 1 electron, right? So here we can say if you want to make it a positive charge, so it must lose the electrons, okay? This is for here. This is the second part of the positive charge and negative charge, okay? And after that, maybe if you want to make it negative charge, so you must gain electrons, okay? You must gain electrons. So like you can find here, like here, positive charge and for negative charge. If you gain 1 electrons in the negative charge, you'll find that the total charge for it is 5 positive charge and 6 electrons. Okay, so here the number of electrons are bigger than the number of the positive charge. That means the total value of the electricity is negative. Okay. So here we discuss about how charges come from. They're just from every single atom. Okay, so please remember this is very important for you to understanding the transfer of the electrons. Okay. And here there's 2 examples for electric charges. Okay, you can find here if you're using your hand and holding a wool to make a like move is poly, you'll find that if it's a rubber receive charger and polysilicon will take negative charge and wool will take a positive charge. So maybe guessing you're not very familiar with what is polysilicon. Okay, so for polysilicon we can say it is a kind of plastic. Okay, so I think this is very easy for you to understand, right? Plastic is very easy, right? So just using the plastic rod to rub with wool, and you find that plastic rod just takes negative charge, and for wool, it takes positive charge. Okay. So we have said before that if an object has a negative charge, that means the negative part is bigger than the positive part, right? So here we have more electrons on polysilicon, right? And for wool, maybe now it is positive charge, so it must lose electrons and make the positive charge bigger than the negative charge, right? So we can set here the electron transfer just from the wool to the polysilicon. So wool lost electrons and become positive charge. And for polysilicon, it gains electrons and to form a negative charge rod. Okay. So this is for policy, okay? So after that, maybe here on the right figure, you'll find a perspex. Okay, so what is a perspex? You'll find here that a perspex rubbed with a wool, and here the perspex that maybe lost electrons and you form the positive charge. So maybe you also very clearly about what is perspex. So perspex is means the glasses. Okay, so I guess here is very easy for you to understand, right? The glass rod just rubbed with wool, and the glass rod takes positive charge and the wool negative charge. So electron must transfer this way, right? So glass lost electrons and to form positive charge, and wool gains electrons and to form the negative charge. Okay, this is for perspex and wool. Okay. So next part we will discuss about conductors and insulators. So what is conductors? So conductors is just like metals. So they're just let electrons to pass through them. So if you are using your iPhone and sometimes it was auto charge, right? So maybe you're taking a wire to charge your iPhone, and you'll find that the wire in the center is made by copper or like made by other metals, right? That is because in the metal here is a structure, and inside of this there are many positive protons inside of the metal, and many electrons are flowing forward and backward in the metal like this way. Okay, so we can say so that the metal can conduct electricity. Okay, like moving forward and moving backward like this way. Okay, this is for conductors. And for insulators, we said that it cannot conduct electricity. And then that means it can produce the substance and out of the charge and make them to stay still. Okay, so you can find for like the wire, you can find there's a plastic like a package packed the copper inside of this, right? Okay, and for this is for the difference of conductor and insulators. Okay, And here's a very classical problem. When I was a student, my teacher asked me to put this question. So for the iron and copper, and for the silver, okay, maybe for just for copper and silver, okay. And we knew that the copper's conductivity maybe is quite similar to silver, and even silver's conductivity is bigger than copper. So here is a question: so that why we don't use silver to become the wire central? Okay, the materials of wire central. So I guess you have an answer, right? It's not very difficult because silver is very expensive. So when you are using silver to build the wire, you'll find maybe in the city you use up a lot of silver. So that's a very hard burdens for the government to shoulder these burdens. Okay, so we are using copper because copper is very normal and common in our daily life. So using copper is very easy. Okay, this is for the conductors and the laters. Okay. And that's the part is about attractive force on an unpowered object. Okay, so here you'll find that a rod is hanging on the in the air. Okay, and here is the uncharged object right here, and you'll find that because of there's a positive charge in the rod and there's negative charge attracted for the positive rod. Okay, like this way. And some other positive charge will just moving downwards and to form at these places. Okay, so we can say that if you're hanging like a metal, like a conductors, it can conduct electricity. So the electric charge can be induced. Okay, so we call this induction. Okay, that means some charges are induced to the top or to the bottom. Okay, this is a kind of induction. Okay. So many times you have induction, like you're close into your sweater and you'll find that there's a bleeds on your hand, right? That means that you have a static charge, right? So this is a kind of induction, okay? Okay, and another example is for earthing, okay? And for earthing, maybe you'll find that it's from the basic word earth, right? So this is a word for the earth, right? So it just means connected to the ground, like this way. You're using wire to connect with the ground. So how this works? And that is because the ground has unlimited positive charge and negative charge, like here. Many positive charge and negative charge in the ground. So for each particles or each electricity wire, if there's a substance connected with the wire and the ground, you will find that maybe if it takes positive charge, and maybe just a few seconds, also just maybe for very quickly time, very short period, you'll find that positive charge is attracted by the negative charges. So positive charge just moves downwards, and you'll find that they neutralize together, and there's only no charges in the substance. So you can find this is very good for some places that it needs security and it needs to have no charges, right? This is for Earth's uses. Okay, so but please remember that the Earth, although it can hold many negative charge and positive charge, but remember that it has a limitation, or its attractive force and repulsive force has a limitation. If you put another rod right here, okay, there's a positive rod, and here is a substance. So if there's negative charge inside of this and connected with the ground, so this part has more attractive force than the ground because ground is very big and the positive charge and negative charge maybe almost equal to each other. So we can say that the attractive force is very weak for other charging object. Okay, so this is for this part you have to understand. For earthing, right here, you'll find there's a plane that connected with a wire, and maybe this time it is filling with oil. Okay, so maybe you'll have questions. So, well, why it has a maybe a gasoline line or petrol line in the plane, and we have to using this earthing wire. And for this earthing wire, we can say that is because here once we earthed with the ground, so right here for the ground, if the oil is filling in the airplane, maybe for there is a rub with the like the oil with a tube. So maybe here you'll find, oh, maybe there have a static electricity inside of the plane. Maybe here is negative charge or like even positive charge in the plane. Okay. So for plane, you will find that there are many panels, many like the signal apparatus, like we have to put many electrical devices on this, right? So if we take negative charge, that means it's very easy to bomb or like explosion on the plane, right? So it's very dangerous for the plane to take the electricity. Okay, so we must like make these electrons to another places, or just we have to induct them, right? So here, by using a earthing wire, you'll find that, oh, right here, because the ground have a large amount of positive charge and negative charge, so for electrons, they're very easily to flows down from the plane, right? So maybe here you can find the net charge is very easily to goes away, and maybe here is safety. Okay, it is very safe for the passengers. Okay, that is because earthing like this way. So maybe in your daily life, there's also some examples for earthing. Maybe if you're in China, you'll find the China's charging is like this way. Okay, right? This is this form. Okay, maybe when you're in the in the Malaysia or in Singapore, you'll find their charging is like this way, right? So maybe your charging wire, just like I guess it's this way. Okay, I forgot exactly a charge type or the charge shape for the plugins. Okay, so maybe here for the some places, maybe in European, I guess it's like this way or like this way. Okay, you'll find there are three very tiny holes for each plugins like this way. Okay, so why is this? So we said that they're all the three plugins, and this the middle is very important for every like electricity devices. Okay, so for your maybe for iPhone, there's only two part of plugins like this way, right? This is for iPhone, but for like this and this, that means they need to conduct its electricity. Okay. So maybe for your refrigerators, maybe for air conditioners, you'll find that you must to have this small hole to connect it with service. So I remember that maybe many times ago that maybe the refrigerator only has two holes, so that it's very easily to conduct electricity, and maybe people just put their hand on them. It's very easily to conduct electricity, so it's very dangerous. So using this way, you'll find the outer surface for these like electricity devices are connected with Earth, and it's very safe. If one time they have negative charge or positive charge, they will conduct into the Earth very quickly. Okay, this is for Earth and how it uses. Okay. Okay, so this is for today's our lesson. I guess you have already understand for the earthing and some basic knowledges of the electricity. Okay, so let's have a break and see you next time. Bye.